Okay, so I just got a little thrown off because when I was putting in my sigma notation for this example, I got 3,351. So I wanted to show you what mistake I made. So come over back to Desmos with me. Here's what I got. It's right here on the screen. Oh, easy mistake. I just forgot my parentheses. I need to tell Desmos that that entire thing is the function. And now I have 2,871, which confirms what I got with the other formula. So man, look at that, the power of parentheses. I'm sorry, I was getting a little confused at what on earth did I do wrong. I just forgot my parentheses within sigma notation. So glad I went back and checked on that. Okay, so a couple little more review topics here. We are all done with this unit. Our next review topic is a geometric series. So remember, series is a sum. So this would be the sum of the numbers in a finite list of a geometric sequence. The sum of a finite list, which means it doesn't go on and on forever, of the numbers in a geometric series. All right. So, as usual, there's a formula for that. S sub n is equal to big fraction bar, a sub 1 times 1 minus r to the power of n all over 1 minus r. Okay, so make sure we get that formula down right. And a couple of examples. Guys, the way you know it's a finite list is because it tells you where to stop. It's telling me to stop at 12 terms. So my n value here is going to be 12. I'll need an A1 value, so that's the first term of the sequence. So A1 is 2. And I'll need an R value, so you're back to finding the common ratio. So what do we do to get from 2 to 6, or 6 to 18, or 18 to 54? We multiply by 3. So my R value is going to have a 3 in it, but also recognize that we're changing signs. We're going from positive to negative, negative to positive, positive to negative. So the R value is a negative 3. So now we're ready to put everything into the formula. We're finding the sum of 12 terms in this sequence. The first term is 2. R value is negative 3. And the n value is 12. Okay, from here, be really careful over in Desmos. You just saw what happened when I put parentheses in the wrong spot. Okay, so get your parentheses in the right spot, and you should get a sum of negative 265,720. Okay, one more example to go. You guys, as soon as you see a sigma notation, I hope you're just going to jump over into Desmos. So I'm going to go over into Desmos and do a better job this time of putting everything in the right spot. Got a lot of stuff here. All right, sigma notation. They're using an m as the variable. Whoops. All right, so from 2 up to 8, negative 512 times p over 2. Now don't forget right here, when you put this in parentheses, you need to put the whole exponent in a set of parentheses. So that entire m minus 1 is raised up in the parenthesis position. Without that set of parentheses, look at what it does. Well, it didn't do it because I did it right the first time. M minus 1. It drops it down. See, it drops it down. So I need it to stay up here, so I have to put the exponent in m minus 1 all in parentheses. I get negative 24,708. Again, working on Desmos. Okay, One more thing to go. And it is your infinite geometric infinite geometric series. You guys, it is definitely a sum because it's still a series, but it's the sum of an element in an infinite series, and the only ones we're really worried about is the convergent series. So it's the sum of numbers in a convergent series. Now, if you need a repeater here of what a convergent series is, that is where the R value has to be less than 1. The absolute value of that R value has to be less than 1. And here's your formula for that. A sub 1 over 1 minus R. So we'll know it's an infinite series because it just says find the sum. It doesn't tell us what to stop at like all the rest of these have. So it just says find the sum of the whole thing. All right, so some things we need. We're going to need our first term again. A sub 1 here is 400. And then the only other thing we need is our R value. Now the R value is going to tell you whether it's convergent or not. So what do we do to get from 400 to 200 or from 200 to 100? We divide by 2, which makes our R value 1/2. So this is convergent. So we would keep going. We can find the sum. So the sum of this infinite series would be 400 is your initial term over 1 minus 1/2. You're going to get a final answer of 800. Okay, one more example to show you. This is sigma notation. So I think I'll take it over into Desmos, but before I do that, let's just confirm that this is convergent. To do that, I am going to use my geometric sequence formula from way over here. So there's my A sub 1, it's 48. The R value is negative 1/4, which means convergent. If your absolute value of the R value is less than 1, then it's a convergent series, so it will have a sum, so we continue. So I'm going to take this over into Desmos to find the actual sum. It says start at 1. We're using y as our variable. And go to infinity. Now remember, you can't do infinity, so I'm going to put 100. 100 seems to do the trick for me. 48 times negative 1/4 to the power of y minus 1. And I am getting 38.4. Okay. Yes, I hope this little page was a good summary of all those different formulas. I know it's a lot to keep up with, but this would be a great study page. And even if you just get the top done, it'll be a good list, and then you can swap out what examples you want to use. But keep studying, keep practicing, and come see me if you need any help. Happy studying!